In this video, I'm going to show you 3 critical data scenarios that every serious VBA user should know. Understanding these scenarios is essential as they form the foundation of nearly every VBA application you'll create. For each scenario, I'll explain exactly what it is and demonstrate various VBA methods you can use to handle them. I'll also show you the pros and cons of using each method, helping you decide which approach is best for your specific needs. My name is Paul Kelly and I've been writing software for 30 years with the last 10 spent teaching people how to write high quality Excel VBA code for real world applications. And I'm also the recipient of 3 Microsoft MVP awards. Make sure to download the cheat sheet from the description below the video. It provides a quick reference guide to the scenarios and techniques covered in this video. So let's go ahead and get started. Let's explore the first scenario, filtering data. Now, if you've worked with data manipulation in VBA before, you will be familiar with this concept. In this scenario, we aim to extract a specific subset of records from our original dataset based on a certain criteria. So for example, we might want to retrieve all records related to Apple, resulting in a filtered dataset that looks like this. And similarly, if we want to extract all records containing orange, our results would look like this. There are numerous ways to apply filters, but the main idea is to obtain a subset of the original records based on a defined criteria. Now let's look at the different VBA methods for filtering data. This is the data we'll be filtering, and we're going to filter on the product column. We'll write the filter results starting at cell H2. Now here is the code for filtering the data using a for loop. First, we get the range of the data using current region, and this will include all the adjacent data. Next, we set the output row variable, which we'll use to track the output row when we copy the filtered data. The next thing we do is clear the output range so it doesn't contain any data from previous runs. The main part of this process involves a for loop that iterates through each row of the range. And for each row, we use an if statement to filter the data. So if the product column matches widget A, we copy the current row to the output. We then update the output row variable to point to the next row. Now this is a pretty standard way to filter data using a for loop. And if you're dealing with a large amount of data, then you should consider using arrays to make sure that the code runs at optimal speed. Another way to filter data is by using the advanced filter, a powerful tool available under the data tab in the ribbon in the sort and filter section. Clicking on advanced options opens the advanced filter dialog. To use advanced filter, we need to specify 3 ranges. List range, which is the data range we want to filter, criteria range, which is the criteria for the filtering, and copy to range, which is the output range for the filtered data. We can use advanced filter in VBA code, which is both simple and powerful. The main advantage is that the code remains unchanged even if we modify the filtering criteria. We just assign the ranges and call advanced filter on the data range. Here is an example of how it works. We want to filter by product widget A, so we place widget A under the product heading in our criteria range. We click the button to run advanced filter and you'll see we got the expected results. To filter by quantity, we add quantity to the criteria and we set it to be greater than 5, and then we remove the product widget A. And when we run the code, you can see that it returned all the records where the quantity is greater than 5. And this didn't require us changing any code. So the advanced filter supports various operations such as contains, exact match, does not match, starts with, and so on. And it even allows using formulas for complex criteria. In addition to being flexible and requiring minimal code, the advanced filter is the fastest way to filter and copy data, making it extremely useful. Advanced filter does one job really well, which is filtering and copying data. But if you need to do more advanced tasks with your filtering, like appending data or grouping data, then you'll need to use a different method. Method number 3 for filtering data is using ADO, which is short for ActiveX Data Objects. Now ADO is used to run queries on data sources such as databases, but we can also use them with worksheets provided that they are in record format. This is the code for ADO, and you might think it looks a bit long-winded. However, 90% of this code will be the same every time, The main change in the code is the query and the worksheet names. You can see in the query that we use the where clause to filter the data. When we run the code, you can see the results have been written out to the worksheet. Now, the advantages of ADO is that it allows us to run many different types of powerful queries. We can use it on closed workbooks, and only the queries change in the code. So most of the code, as we said, will be the same every time. The disadvantages is that you do need to know how to use SQL. And the second thing is the worksheet must be in record format. If it's not, then you'll need to use an alternative method. And finally, ADO is slower than using advanced filter or using arrays, but this is only really an issue if you have a large amount of data. The second data scenario we face in VBA is grouping data. This is where we take a category and we get the sum, average or count of items for that category. For example, this is how grouping by Apple would look for this sample data. We end up with one record for Apple with the values for each original record added together. When grouping, we create an entry in our output data for each unique item in the specified column. You can see here that we have one entry for each unique fruit in our original data. In simple terms, we can say that grouping data is providing a summary of data similar to how a pivot table works. And we can use a pivot table for certain cases in Excel. However, there are also many cases where a pivot table is not suitable for our requirements. So it is important to know how to group data using VBA. The first method we will use to group data is with a for loop and dictionary. A dictionary is like an array, except that it stores a key with the value. And the reason for this is that you can directly access the value without having to go through all the other items in the dictionary. I've covered the dictionary along with its many uses in my effective Excel VBA course. Now, as we go through the data, we read each record and add it to the dictionary. For example, the first record is plum with a value of 77. So we add plum as the key and 77 as the value. Next, we read orange with a value of 15 and we add it to the dictionary. And then we read apple with a value of 15 as well. When we encounter orange again, we can see that it is already in the dictionary. Therefore, we add its value to the existing value. So 77 plus 15. And we do the same for the next apple entry, adding 30 to 15 to get 45. And then adding 73 to get 118. And the final plum record, we add 10 to the existing 77. When we finish this process, you can see that we now have a grouped data set. All we have to do is write this data set directly to the worksheet. Let's take a look at the code for doing this. Here is the code for grouping data using a dictionary. We first of all get the range and remove the header. Next, we create the dictionary that we're going to use. We then read through all the data using a for loop. For each record, we store the product and quantity in variables, as this makes the code clearer. So this key line of code finds the value associated with a product using the key, and it updates it by adding the new quantity. If the product doesn't exist in the dictionary, it automatically adds it. This one line is all we need to group values in the dictionary. Once the dictionary is populated, we write the data back to the worksheet. The dictionary keys and values are stored as arrays, so we can write them directly to the worksheet. However, a one-dimensional array will be treated as a row, so we use the transpose function to convert these arrays to a column on the worksheet. Now, one important thing to keep in mind is that using transpose has a limit of 64,000 records, so if you're using more than that, you'll need an alternative method. And a second thing to keep in mind is that I've used ranges here, so if you're dealing with a lot of data, you should replace the ranges with an array. Let's run this code, and you can see that it wrote out the group data as expected. So we've got widget A, widget B, widget C, and we've got the total quantity for each one. We've just seen how to group data where there is a single value, but what if there are multiple values that you want to sum? For example, here we have quantity and sales total, and we want to get the total of both columns for each fruit. And I often get asked how to approach this since a dictionary only takes one value per key. Well, there's two main ways to do it. So let's look at the first one, which is using a class module. Firstly, we create a class module with the variables we need. So for example, we'd have quantity and sales total. And when we read through the data, each time we meet a new fruit, we create a class module for that fruit. So for example, we create a new class module instance for plum. Then we do the same for apple and orange when we meet them for the first time. So when we meet the fruit after this, we simply update their values in their existing class module. Let's look at the code. First, we get the range and create the dictionary. Next is the important part. We declare a variable of our class module named oTotal. You can see our CLS total class module here. It is very simple and contains two variables for storing the totals. So because we cannot store two variables in a dictionary, we store a class module object instead, and this can have as many variables as we like. Going back to the main code, we read through the data one record at a time. If the product does not already exist in the dictionary, then we do the following. We use the new keyword to create a new object based on the class module. In other words, VBA will create two new variables in memory, quantity and amount. The beauty of the new keyword is that it gives us the flexibility to create as many class module objects as we need while the code is running. Once we create the object, we then add it to the dictionary where we can retrieve it as necessary. So going back to the if statement, if the product already exists in a dictionary, which means that we've created it already, then we do not create a new object. Instead, we retrieve that object from the dictionary. And we do this by providing the key to the dictionary, which is the product, and we retrieve the object to our variable, which is oTotal. After the if statement, the oTotal variable is referencing an object. So it's either the one that we just created or one we have retrieved. We update the quantity and the amount variable by adding the new values from the current record. And when we've all this done, we will obviously want to write out the values to the worksheet. So if you look at the code for writing out the values, you can see that we need to write out each value individually from the class module instances. So it's not like an array where we can just blast everything out to the worksheet in one go. Now in the next method, we'll look at a way that we can use the array. But the class module method is nice because it's actually easy to read and it's easy to update. Now if you find using class modules like this a bit complicated, I do provide the code in my effective Excel VBA course. This method groups data using a dictionary and an array instead of a class module. And here is how it works. When we read the first record, which has plum, we add plum to the dictionary as the key. And we then set the value to 1, which indicates its row in the array. We then place the data relating to plum in row 1 of the array. The next record has orange as the fruit, and this isn't in the dictionary either. So we add orange to the dictionary, and then we use the value 2. And the value 2 then will point to row 2 in the array. We then place the data for orange in row 2. And we do the same again for apple. When we encounter an item that is already in the dictionary, we retrieve its row from the value. So for orange, the dictionary indicates row 2, so we update the values in row 2 of the array. Once all the items have been processed, we simply write the entire array to the worksheet in one operation, which makes this method extremely fast. Now let's look at the code for implementing this method. First of all, we get the range, and then second, we create the dictionary and the array. We set the array size based on the number of rows and data, but we will only output the number of rows that are in our group. So in this case, that will be 3. Next of all, we initialize the variables. New row ID variable points to each new row, starting at 1 and incrementing by 1 every time we add a new item. And current row ID stores the current row when we retrieve it from the dictionary. So the fourth thing that we do is processing the data. We store our values in variables as it makes the code readable, and then we check if the item exists in the dictionary. Now if it doesn't exist, we add the item and assign a new row ID to it. Then we insert the product name in the array at that position using new row ID. And then we add 1 to new row ID so that it's ready for the next item. Now if it already exists, we don't have to do anything. So after this step, once the item is in the dictionary, we can retrieve it using the current row ID for the item using the product name, which is the key. We now update the array using current row ID by summing the quantities and the amounts. Step 5 then is to write out the array. So we set the array size to the number of unique items counted, that's new row ID -1. We clear the worksheet contents and we write the array to the worksheet in one operation, which makes this method much faster than using class modules. Now for optimization, we can use a helper function array to range to simplify writing the array to the worksheet. So when we run this code, you can see that it gives us the product with the quantity and amount columns summed. The final method for grouping data is using ADO, and to be honest is probably the best. You'll notice that this code is similar to ADO code we use for filtering. The only difference is in our query, all the VBA code remains the same. Now if you're not familiar with SQL, I'll explain it briefly. In the query, we specify the fields we want to select. These fields are returned from our data, which is located on our sales ADO worksheet. When we say group by product, it means the data will be grouped by the product, just as we've seen before. For any field not included in the group by clause, we need to use an aggregate function like sum, medium, or average. And in this case, we're summing the quantity and amount while grouping by product. When we run this code, we can see in our sales ADO output worksheet that we got the data as we expected. So it's grouped by product and it's summed by the two columns. However, you might notice the field names are a bit strange, like expression 1001. We can easily fix this by going back to the code and using the as keyword to rename the columns. Running the code again will then display the correct field names. Overall, ADO is probably the best method for grouping data if you can use it. It is the simplest to implement, although it doesn't run the fastest. As mentioned, if you're writing code for filtering and grouping, the ADO code doesn't change, only the query does, and this makes it very efficient and easy to work with. So if it's suitable for your needs, then this is probably the best method to use. The final data scenario that we will be looking at is joining data. Imagine we have a dataset containing information about various fruits and the respective volumes. Additionally, we have a lookup table that lists the prices of these fruits. Our task is to create a report with all the sales data, but also including the price for each fruit. So for example, for the first record plum, we take the name and volume, and then we use the name to look up plum in the price table. And our final record will then contain both the volume and the price for plum. Now a second example, we're going to do the same for orange. And again, we combine the records to get the output. Joining data from multiple tables is a common operation in databases. Now, while it's possible to perform complex joins involving numerous tables, here we're going to focus on a simple join for this video. Now let's look at the different ways we can write the code to join data. Let's go through the code. I've divided it into 3 parts for clarity. The first one, retrieving customer data. So first we extract customer data and store the details in a dictionary. So this will make it easier for looking up later. We read through the range using the email as the key and the name as the value. And then once we're finished reading through all the data, we simply return this dictionary to the calling sub. The second part then is creating the report. So in this part, we're essentially processing the sales data. For each sale record, we store the output in an array. And we fill it from sales data, the fields email and amount. And then we use the dictionary to look up the customer name, which is in the customer data. And finally then we write out the data from the array to the range using the array to range helper function. When we run the code, you can see that it wrote out the email name and amount, but not the city field. And the reason is, as we've seen before, is that the dictionary can only store one value. So if we want to store multiple values, then we would use a class module to store all the fields, like the code here shows. When we run this code with the class module, you can see that it wrote out the data as expected. Now, while this code works fine for joining code, it does begin to get very complicated if we were dealing with more than 2 tables. And that's why the next method using ADO is probably better when it comes to joining. Now let's look at the ADO code for joining data. To make our script clear, I've organized the data into different worksheets, the sales worksheet and the customer worksheet. Again, the VBA code is pretty much the same as the ADO code we've looked at before, the difference being the output worksheet name and what we write in the query. In our query, we use left join, which will automatically join the data in the two sets of data on the email field. So essentially, using join connects two tables of data using a common field, creating a single unified table from which we can retrieve the required data. So when we run this code, you can see it gave us the output as expected. If you want to know more about the topics discussed here, then check out the videos on the screen. See you in the next video.